Hello, it's Mr. Baird. We're going to talk today about special right triangles. But before we do that, we have something we want to add to simplest radical form. So you've been working with factor trees and taking square roots, like the square root of 40, and rewriting it so that there aren't any perfect squares left over inside the square root, right? So we've done plenty of practice with that. But another thing we want to add is that square roots in the bottom or the denominator, they just don't really make sense. I mean, what would it mean to divide by the square root of 2? Like, how could we visualize that? The square root of 2 is irrational. It goes on forever and ever and ever. So we're going to use a strategy to get rid of these square roots in the bottom. And the strategy is to go ahead and multiply top and bottom by that root in the bottom, because we know that the square root of 2 times the square root of 2 is 2. And you might be asking, well, why is that? Why is that true? Why does the square root go away? Well, think of it for something like 9, right? The square root of 9 times square root of 9 is 9. And the reason why is because these are both 3, right? So that gives you a little bit of support of why the answer is 2 in the bottom. And multiplying across the top, we get this. So this makes a lot more sense, right? Dividing by a whole number. So we prefer that, and that's an extra requirement that we have. So this one too, we'll do that same strategy. And we will get 5 here in the bottom. But of course, these are all multiplied together and the 5's divided, so it's almost as if the 5 can be canceled away, and we get 3 square root 5. Okay? So that's those two. And this last one here, exponent rule says that we can take the square root of the 2 individually, the same reason why something like this is equal to, we can split it up. So multiplying 2 roots, they merge. Dividing 2 roots, they merge as well. So then we simplify, and then we use our new technique of multiplying by the radical in the bottom. And there you have it. So that's how you take the square root out of the bottom. It's a new way of adjusting these fractions, is by getting rid of that root. So that way it's simpler to understand. Okay, so that's that. I'll leave that up there. And to move into these special right triangles, let's take a look and see if we can solve for everything, 3 sides, 3 angles in this right triangle here. So this is 90, of course, and the 2 sides are equal. The 2 legs, we call them, are both 5. So if we want the third side, well, why not use Pythagorean theorem? 5 squared plus 5 squared is x squared. And remember, the order at which these go in is important. The x is the hypotenuse, so it always goes last. Okay. So we got 25 and 25, which is 50. The goal is to isolate x, so we'll take a square root. And normally we would have a plus or minus here, but distances are always positive, so we'll just keep the positive root. But 50, we can break up into 2 and 25, right? And you could finish this tree 5 and 5, right? But I'll show you another way. So if you're really comfortable with the tree, go with the tree. But it's actually a little bit faster to break it up so you have a perfect square. And then that's ready to come out. Perfect squares come out and get square rooted. So a little bit more quickly, we get the answer 5 square root 2. Or you could have done here and then 5 and 5. So This here is 5 square root of 2. But what about these two angles? So let's call this one A and this one B. Let's start with A. So remember that we have all 3 sides. So when we think about solving for an angle, we use trig to do that. And we can set up any trig ratio we want because we have opposite, hypotenuse, and adjacent. We can do whatever we want. So I want to pick the ones that have the whole numbers. So how about opposite and adjacent? That would be tangent. So tangent of an angle is opposite over adjacent, and both of those are 5. Okay, and then to get rid of the tangent, we have A. We can't divide by tangent because it's tangent of A. They're not multiplied. So we got to take tangent inverse of both sides. So why did you do tangent inverse? Well, it's the special function that cancels the tangent. They're called inverses. So that means that A, the angle, is tangent inverse of 5 over 5. And using your calculator, we can see that that is equal to 45 degrees even. Okay, so we're almost done here. But if we have a 90 degree and a 45 degree, this one needs to be 45 too, because they all have to add up to 180, the angles. Okay, so that's it. We solve for the 3 angles and the 3 sides. So let's summarize here. We call this a 45, 45, 90. I will fill that in here. And so what we're seeing here, what I want you to focus on is this 5 and the hypotenuse. What's the relationship? How do we change 5 to 5 square root 2? You multiply it. So the hypotenuse, the long leg, the long side of the triangle, is square root 2 times the leg. All right? So this is a leg, this is an equal leg, and this is the hypotenuse. So I just used 2 equations, right? The first one's kind of maybe obvious. The leg is the leg. The 2 legs are equal for the 45, 45, 90. And then that sentence is talking about how the leg times the square root of 2 is the hypotenuse, okay? So it's those equations that we're going to use to solve the triangles on this packet here. All right? So solve for the missing side. Well, this one's real quick because the other side is 9. The other leg, I mean. And to get the hypotenuse, you multiply by square root of 2. We just said. So we're kind of done with that one. How about if one of the legs is 5 square root 3? What's the hypotenuse and what's the other leg? So zoom in here. So once you see it's 45, 45, 90, I would really recommend that you write down the equations. And you'll need to know these. We won't give you these. So if the leg is the leg, then this has to be the same. And to get the hypotenuse, we ought to look at the equation that has hypotenuse in it. So this equation is going to become 5 square root 3 times square root 2 is the hypotenuse, right? Just plug it in, plug in the leg. And then this can be simplified. We'd rather have 1 square root when we put in simplest radical form. So we'll merge those together underneath. and then we solve for the hypotenuse. Okay? So that's all we're doing, is you just got to write the equations and use them. So this one too, it's a 45, 45, 90. I'll write my two equations. And 6 is my hypotenuse, and these are my legs. So we know the hypotenuse. So let's again use that bottom equation and plug in what we know. We know this is 6. So dividing by the square root of 2, we get that the leg, both legs, right, is 6 over square root 2. But what I told you earlier, that's not in simplest radical form. We got to get that square root out of there, out of the bottom. So we choose our, multiply the same to the top and the bottom, and then right away, we even get rid of the fraction as a whole, which is a big success. Much simpler than dividing by a radical. So that's the leg. So both of these are 3 square root 2. So you'll notice if you multiply this times square root 2, you get 6. So visually, that's what's going on. Visualize the leg's the same, and if you want to get the hypotenuse, you multiply by root 2. So you can think with the equations, but you can also answer these triangles visually. Okay? And then real quick, we have a softball game. We have that the bases make a square. So we have home plate here. So first base, second base, third base, and home. And they're talking about throwing the ball from home plate to second. All right. Now I would pause the video right now and see if you can do the rest of the problem. All right. So here's how you do it. This will be our triangle. And it tells us that the spaces between the bases are 60 feet. And it wants to know this one. So I call that the hypotenuse. And I call these legs. So if you remember our equation, hypotenuse is the leg times square root 2. All you got to do is just say, hey, 60 is the leg, and you're done. So special right triangles are called special because we don't need to use sine, cosine, tangent to find the sides and angles. We can just use these special relationships. So that's the real big takeaway from today. Let's talk about 30, 60, 90 triangles too, the other special type. So if we have this, what is x? We need that. We want to solve for all the rest of the parts, which we're missing 3 parts right now. So Pythagorean theorem, a squared, b squared makes c squared. A and b are the smaller sides. So whenever you plug something in that's complicated, use parentheses. Because it's really hard to square something like that. And if you use parentheses, you can remind yourself that, hey, squaring just means multiplying it by itself. And you might have a better chance of getting this correct here. So 4 things, 4 square root 3, 4 square root 3. You can multiply them together in any order you want. So how about 4 times 4 is 16, and square root 3 times square root 3 is 3. So, because it's really easy to get that exponent, the squared, wrong. So I like to write it out, expand it out, see what you have. But anyways, we'll continue, and we will get 8 for for this. Okay. Angles. Let's go for angle B again. So this is 8. So if you want to solve for an angle, you need to either know the other two angles or know some sort of trig equation. So again, opposite, hypotenuse, and adjacent. What we're doing right now, finding this angle, is almost it's the best representation of what this next test is going to be. You gotta be able to do this. Label a triangle, set up the ratio, and do something to it. So I'm going to choose, we have our choice, sine, cosine, tangent. We know all three. But I'm going to choose the ones with the whole numbers. So how about opposite and hypotenuse? That means that, not tangent, sine is opposite over hypotenuse. So sine of B, opposite over hypotenuse, which is equal to 4 over 8. So that B is inside, it's the input to the sine. So in order to make that sine go away, remember we took those inverses of both sides. So sine inverse of this side and sine inverse of this side. So this is B. So the sine inverse and inverse, the sine inverse and sine, they dissolve, they cancel each other. But over here on the right, we have this. Okay? And you can trust me, if you use your calculator on this, we get a nice 30 degrees. And I already kind of spoiled it to you, right? 30, 60, 90, so 60 must be this one. And all those add to 180, so we're confident there, as long as B is 30 degrees. So that's it. That's our second special right triangle. So let's break that down again. Let's summarize. So 30, 60, 90. In a 30, 60, 90 triangle, the length of the hypotenuse, let's see. So look how this 4 and this 8, 4 times 2 is 8. So the hypotenuse is 2 times the length. And if you play that same game with this side, it looks like if you take 4 and you times by square root 3. So let's read that sentence again. So the length of the hypotenuse is twice the length of the short leg. And the length of the long leg is square root of 3 times the length of the short leg. So that's a big mouthful. Let's actually write that down. So we're going to call this the short leg and the long leg and the hypotenuse. So this must be the 30 and the 60, because the short leg is, it's opened up by the 30 degrees, which is smaller. So it's a small leg, short leg. So the equations are short leg times 2 is the hypotenuse, and short leg times the square root of 3 is the long leg. This is huge. Those two equations will help us solve every 30, 60, 90. Okay? So if you wanted to, the simplest 30, 60, 90 would be when the short leg is 1, the long leg is square root 3, and the hypotenuse is 2. So it's just using those equations when the short leg is 1. Sometimes I visualize the 30, 60, 90 as that particular 30, 60, 90, the simplified one. That's enough talking about that. Let's solve for x and y here. So when you see it's 30, 60, 90, write down the equations. We have the short leg times something, short leg times something. Okay. So then maybe do some labeling. Labeling will really improve your chances of using these equations right. Because when I see the short leg next to the 12, I know what I have to do. I have to just copy down these equations, but plug in the short leg is 12. And this one's really 24. But that alone, it answers the question. I think we're done. It's 24, and this is 12 square root 3. So if you focus in on just the numbers here, we can see this doubling and then this scaling up by square root 3. So visually, that's how each of these are going to work. So if you're a visual person, that's what you're going to go towards, is these arrows. But if you like the equations, you can use the equations. Okay, so let's wrap up these last three. So again, give me a second to write these down. All right, and then you have to say, well, what do we know? What do we really know here? The hypotenuse is here. 30 degrees opens up to the short leg, and this is the long leg. Okay. So if you want to, I mean, this triangle has everything labeled nicely. You could do something like this. Short leg, that's X. Long leg, that's Y. Short leg, that's X. Hypotenuse, that's 40. So this is a good strategy. If you can label everything precisely and plug them in, we can then solve this, you call it a system. It's got X's and Y's in it. But one of the equations looks a lot more friendly. This one. That means that X is 20. So the short leg is 20. And then maybe I could plug that in to the other one. I call that back substituting. Hey, that wasn't too hard. So it's all about labeling. This chapter is all about labeling. Okay. Let's do this one strictly with the equations. So same triangle. Long leg is 12. So rather than using X and Y, let's try this time and just use SL and hypotenuse. And we can even put long leg down here too. And the question's asking for the other two legs. Okay? So, always write down the equations. So, copy them down for you. Right? We only know one of the legs, so we better use that. You know, we have to use that. So let's attack this first equation. We know the long leg is 12. We don't know the short leg yet, but that's fine because that's the only variable left in the equation. Do a little equation solving, and bam, we have the answer. But it does say simplest radical form in the question. So we have to take that extra step to adjust the fraction by square root 3 over square root 3 to make this a 3 and this a 12 square root 3, which this happens to be 4 square root 3 because 12 cut into 3 parts is 4 each. All right, perfect. 4 square root 3. And then the hypotenuse is going to be double that. So this equation now I'm going to plug in the short leg. I know that now. And these three things multiplied together, let's combine the whole numbers, multiply those together, and just like that, we have our answer. So the short leg times 2 is the hypotenuse. The short leg times square root 3 is 12. Okay. Last one. Pause the video and give this one a shot after I draw this picture for you. So escalator means we're going up. It says it's 25 feet above the first floor. So this is like the first floor, and this is the second floor. And then it also says 30 degrees here. All right. So to the nearest foot, how far does a person, like this little guy, have to travel from the bottom to the top? So just like this. Well, I don't know what that is. Call that x. So now I want you to pause the video and see if you can solve for x using those two equations. Write them down. Using our two equations, what is x? All right, go ahead and pause. And did you guys see that this is the short leg? And then we could just immediately use this. And then this is what? The hypotenuse is x. 25 times 2. How about 50? 50 feet? Just double the short leg. And that's it. Okay? All right, that's it. You have some homework down here. And we will help you on how to collect that and submit that. We'll go through that with you now. So thanks for watching. That's it.